now, as part of our brown bag lecture today, we have Draydan Power, and a couple of our regulars here at the brown bag lecture said, we saw him do a presentation at the college. And so I'll do a little plug for the college because they also have a speaker series on Monday evenings. And they said, you should get Draydan in. So I said, I can do that. Because Draydan also works for the city, because that's what I do. And I said, Draydan, we heard some good things about you, and you should come and talk about the future of the electrical grid. And so Draydan is the manager of energy and the environment, and born and raised in Summerland. And so he's going to tell us about how things are changing and what we need to be prepared for in the future. So I'll turn it over to you, Draydan.
Thanks, Chandra. Hello, everyone. Hello. Can you hear me okay? Perfect. Coming through loud and clear. Excellent. Okay. Well, thank you for having me this afternoon. It's great to see such a good turnout. Yes, I've given this very similar presentation at the college, and it's not very hard to convince me to do it again. It's my favorite topic to talk about, so I love doing this kind of thing. So first, I'm going to talk about who am I? Why am I qualified to talk about this? Am I qualified to talk about this? Well, I'll let you decide after you learn a bit about me, and at the end of the presentation, hopefully you agree. We'll go over a bit of electricity in our region. We'll talk about electricity today, how it works. We'll talk about electrification, the oncoming onslaught of heating, cooling, and transportation. We'll go over distributed energy resources. I'll explain what those are. It's a fun term, though, and a good acronym. And, of course, we'll talk about the future. Okay. Let's start with who am I? So as I was introduced, I was actually born and raised in Summerland, BC. So this is a picture of Trout Creek, which is where my family's from, about as far back as I can track them. And I didn't make it very far in the end, but that's by choice. I love it here, and I wanted to be back here, and what a great opportunity to do it. So from Summerland, I moved to the University of Victoria out on the island, and I completed my electrical engineering degree there. While I was in school and following school, I worked for FortisBC for 10 years. So this image that you see here is one of the hydroelectric generating stations in the Kootenays. Okay, so this is just south of Trail. This is Waneta Dam, and the American border is actually right there. It only takes about 1 minute to drive there from this dam here. And you can get some beautiful views such as this from the superstructure up there, and I took many pictures, so I only got one more for you though. This is from Brilliant, and now Brilliant Dam, I'll show you where it is in this presentation, but Brilliant Dam is just outside of Castlegar. So this is from the tail race here on a wintry day, but still beautiful in that area, and I quite enjoyed my time in the Kootenays living out there for a number of years, rotating around to all the different departments that FortisBC had to offer in their engineering. So I did generation, transmission, distribution, substations, smart metering, system control center, protection and control, all of these kinds of different aspects of how power works in the interior here. Okay, from there, I moved back to West Kelowna as I started a family, and everyone knows when you have a family, it's better to be around family for that. So my folks are still in Summerland. We moved to West Kelowna, and I worked over in Kelowna for FortisBC as the transmission and distribution standards engineer. So this is where I became really familiar with power lines and that end-level service that we offer to customers, the distribution system. Obviously very relevant here for Penticton as we operate our own distribution system. Now I swear there is a power line just above me in this photo. It's not just me wearing my PPE out for a nice hike. So this is in Princeton actually. There's a beautiful valley crossing line there that I had to do some work with. Okay, before I left FortisBC, my last year there, I was the manager of EV infrastructure and investment. So it was a new department that I had started dedicated solely to electric vehicles. How do we manage that oncoming load? How do we deploy fast chargers? This is an image from the Naramata fast charging station that I partnered with the Regional District of the Okanagan-Similkameen to install. It's one of our most beautiful sites, actually. It's a pair of 50 kilowatt flow chargers, fully accessible, available to the public 24/7. It was a great installation. Then I left FortisBC. So in January of 2023, I started with the City of Penticton. Now, I came in as the electric utility manager, but relatively quickly, I wanted to morph the scope into a little bit more climate action. I'm quite passionate about sustainability, and I find it difficult in today's age to disassociate or disentangle climate action from electricity. I think those two are pretty much inextricably linked for at least the next few years. So we are brought together now into the Energy and Environment Department, which is climate action and this electric utility. So this is a photo from our Public Works open house where we were able to show the community a little bit of our tools and our staff and what we do on a day-to-day basis. We were able to take people up in a bucket ride. It was very fun. You got a beautiful view of the yards. And then finally here, they actually let me climb a pole. So I wasn't allowed to do that at Fortis. They let me do it here. It's actually just good photography. I'm only about 2 feet off the ground, but it certainly looks like I'm high up there. So just believe it, believe it. Okay, so that's who I am. Let's talk a little bit about electricity in our region. So that is an awesome photo of the Lower Bonington Dam, the very first dam that was built, 1897. This is in the Kootenays, okay? It's just in between Castlegar and Nelson again there. Now this dam was pretty much only built to service, yes, the surrounding town, but that town was really supporting the mine in Rossland, okay? So as you can see here, this is another distribution pole. It looks a little different when we raise a pole today, but it's still impressive that they were able to do it like that back then. And this is again feeding that mine. So West Kootenay Power was around for a while. It sold to Cominco, which is now Teck, as you know, in 1916. Didn't last long, though, because Cominco sold it to Utilicorp in 1987. After that, Utilicorp changed its brand to Aquila, and Aquila, very quickly, actually about a year later, sold to Fortis Incorporated, okay? And that's when it became FortisBC. Their service territory has reached out into the western part of the interior, and that's about the battery lines that we see today. So just for relevance, FortisBC's territory, including the municipal utilities such as Penticton, Summerland, Grand Forks, and Nelson, they go about as far southwest as Princeton, about as far north as Lake Country, about as northeast as Caslow and Crawford Bay, and then as far southeast as Creston. That's the FortisBC service territory. But as I mentioned, yes, there are 4 municipalities within that territory that manage their own distribution system, us being one of them. Last, just before I move on, I want to mention the Columbia River Treaty. It's quite in depth, but it's very important this year specifically. This was a piece of legislation that was developed by the American and Canadian governments. And what it is it led to the creation of 4 dams, 3 of which are in Canada, 1 of which, Libby Dam, is in the States. And that Libby Dam actually backs up its head ponds into Canada. Now this is important because the US pays us a lot of money every year for this agreement. That agreement is technically up this year in September of 2024. Yeah, the federal governments on both sides have been, long at work trying to figure out what to do as the next move. If nothing happens, the dams don't get destroyed. It just continues as it is today. But I know that America will be obviously trying to renegotiate the terms of that contract as we make about $200 to $300 million a year as the federal government, most of which comes to BC. Okay, so what does electricity look like today? It's unidirectional. It's generated, it's transmitted, it is distributed, it is consumed. And that is the relationship. And we'll walk through each step of that. So these are more great shots of those dams in between the Nelson and Castlegar area along the Columbia River. And once that electricity is generated at these dams, which are actually over here on this transmission map, it is stepped up to transmission voltage so it can be transmitted across the interior of British Columbia. Now, the majority of power on any system, FortisBC Hydro or anything, it goes along these bright red 500 kV lines because they are the most efficient, okay? So it reaches Ashton Creek up here, and it reaches Vaso Lake down here, which is just north of Oliver, and then it steps down at about 230, still quite high transmission level voltage, nothing we have around in the city that we own, and eventually it reaches Penticton, okay? So when it reaches Penticton, we have 4 distribution substations, okay? We have Westminster in the north, we have Carmi in the east, we have Waterford in the south, and we have Howth in the west. Now, these 4 distribution substations take that transmission voltage from FortisBC and step it down to distribution voltage, 12.5 kV. That's the voltage we know and love that goes around our city, okay? So you drive by it, it's underground. This is what you see. If you see poles with 3 wires sticking above it, that's 12.5 kV here in Penticton, distribution voltage. Now, these 4 substations have a total of 19 distribution feeder circuits across them, okay? Those feeder circuits are essentially what picks up neighborhoods, right? So if you trip an entire feeder circuit, there's probably about anywhere from 500 to about 2,000 customers on each of those. There's some big ones, and I'll talk about Westminster here in a second, that have many more. Now, each of these distribution substations are redundant. They can back each other up, and that's very important because if you take, for example, what happened in January, we had an outage to the Westminster sub. We lost about 5,000 customers for a couple hours. Now, FortisBC was able to respond and repair this transformer relatively quickly, but our crews were already partway through a restoration switching procedure that would have offloaded the entirety of the North Gateway and this Naramata bench off to Howth and Carmi, and we would have been able to operate normally until that transformer was repaired. Okay, so it's important to know this is redundant. We're able to back each other up, and that's why we have 4 strategically located substations in Penticton. And last, once it's distributed, it goes into your neighborhoods, and then you've probably seen something like this. You might see overhead transformers too. They're the big oval-looking cans on top of a pole. That's a distribution transformer. So is this. This one's underground. This will take that 12.5 kV distribution voltage, still quite large compared to what we use in our homes, and this steps it down to 120, 240. It enters your home, and you use it. And that's how power flows, okay? So from generation to transmission, from transmission to distribution, from distribution to low voltage utilization in your home. Okay, so that's it. We now understand electricity. That's how the whole system works. I'm done. I'll see you later. Thank you so much. No, of course, that would be fine. Status quo would work, except for the oncoming onslaught that I mentioned, which is electrification. We know load is coming. It's regulated to come. We know people want to convert to it. So let's talk a little bit about the 2 main drivers of electrification. Heating and cooling is the first one. So there's a couple things that are contributing to this oncoming load. The first is the zero carbon step code. This is a new program released by the province that has escalating requirements, forcing new builds to be built with zero emission fuel appliances, everything like that. So what does that mean? Well, at level 1, you're monitor only. The city will only monitor who's using gas, who's using electricity. We'll keep a repository of that. And then the escalating requirements go up to the other end of the spectrum, which is no gas fireplace, no gas stove, no gas furnace, no gas on your barbecue deck, nothing. No gas whatsoever. It has to be all electricity or zero emission fuel. And as of right now, it's really only electricity is the feasible other solution. So on top of this, FortisBC recently applied, this is the gas side now of Fortis, not the side I work for, but the gas side. They recently applied for a new pipeline project on the east side of Okanagan Lake between Kelowna and Penticton. This pipeline project was rejected by the BC Utilities Commission. Okay, FortisBC needed this pipeline because they were going to become gas constrained in 2026, meaning not much left in terms of capacity for new builds or increased usage, right? Well, that means that we're going to have to be putting all of this heating and cooling load from 2026 or whenever they're gas constrained onto our electric system, right? And that's fine because it was probably going to come anyways with the zero carbon step code, which has minimum escalating requirements. Again, we have to at least be where the province wants us to be. Okay, so no new gas, lots of electricity. And we know that people are also converting their existing homes. We have a program, and I have to plug this, of course, because I'm on the sustainability side, called the Home Energy Loan Program. If you want to get an energy audit done for your house, so you can see how much energy and how lossy your house is, we will help with that. And as a result of that audit, you can undertake upgrades. You can get new air source heat pump, you can get better windows and doors. All of this is covered with a low interest loan from the city. We are trying to make this program even better in ways like direct pay to contractors, so you don't have to bridge the finances. We're trying to get the interest rate very low, like really, really low, so it just makes sense. And this will hopefully make it more approachable and make it more accessible for everyone who wants to participate in these home energy upgrades. But again, this is adding load to our electric system. You're starting to understand it. And infill development and new construction. Well, this speaks for itself. We know there's a housing need in Penticton. We know we're stimulating development, lots of infill. Well, all of that infill is going to result in electric load because of the zero carbon step code and FortisBC gas constraints. So all of this new building that's supposed to happen, doubling our population in the next 20 years, it's all going to result in electric load. Okay. Then the next arm. Okay, so that's the first. Heating and cooling is the first main driver of electrification. The next is transportation, EVs, okay? We at the city have already created an EV-ready bylaw, which means all those new houses that we're talking about have to be outfitted with electrical systems that are capable of charging EVs, okay? But just because you put an outlet in does not mean it's going to be used right away. People may not buy a vehicle, but pretty soon they'll have to because the Zero Emissions Vehicle Act. BC has also created an act that says by 2035, 100% of new vehicles sold have to be zero emissions. And again, hydrogen has some application. The Toyota Mirai is a beautiful vehicle, but the industry right now is sticking its flag in electric, okay? So that's what it's going to be happening here. And if you don't want to wait for the stick, you can go for the carrot, and that's the Clean BC Go Electric rebates, okay? These are available today. They'll give you a rebate on your vehicle, and it's already starting to dry up a bit. They'll give you a rebate on charging systems, and again, it's not going to be around for long because the stick is coming. So between heating and cooling and transportation, we know that our electric system is going to get hit, and we need to be prepared for it. So what do we do? Well, first, let's look at what's actually happening. I'm going to get into details here because that's the fun part of this. I can really explain it with some very poorly drawn diagrams, and I apologize for that. This is my hand drawing up here, but at least the houses I took from clip art. Okay, so this is the distribution system I was explaining. You got poles and wire up here. This is one of those distribution transformers. It's usually right around here as an oval white can on the pole, but today I drew it in its single line diagram form. So this transformer is about 50 kilowatt. That's the size. That's how big it can handle, how many customers it can handle, 50 kilowatt. Each of these homes here are about 5 kilowatt if they have gas heat, or 10 kilowatt if they have electric heat. And I checked into this after that heat pump was about that same value. Heat pumps can end up consuming quite a bit of electricity in very cold weather conditions, and we want to be building our system to be providing power in really cold weather conditions. So we need to make that assumption it's about 10 kilowatt. So we have 6, as you can see, and if math is math, that equals 60 kilowatts. But we know with diversity that not all of these homes will be cooking dinner at the same time or heating their homes at the same level. So a 50 kilowatt to provide 6 homes, that's plenty. That's plenty. We do it all the time. That's no problem. Until someone gets an EV charger. Well, that's fantastic, right? We're converting. This is great. They took advantage of rebates. This charger that they put in their home can either be between 5 and about 20 kilowatts. So as you just may have noticed, the average home load is about 10. This can be up to 20 by itself. Now, we're barely seeing any installed like that. I think I've seen one since I started here. Most of them are around this 5 kilowatt range, okay? So let's just say that it's about 5 kilowatt. Let's say that for a gas home, you're about doubling your load, and for an electric home, it's about 50% more. But we also know that keeping up with the Joneses is a real thing. So your neighbor gets one, so you want to get one. And then you get one, and your neighbor's neighbor gets one. So now we've taken this poor little transformer that's sized to 50 kilowatts, was humming along nicely, having a great day, and now we are in the middle of the summer. It's August, it's 40 degrees. These 3 people have come home from work, they've plugged in their cars, they've turned on their stove, they've turned on their laundry, they've turned on their music and their lights, and lo and behold, this transformer is no longer very happy. It's having a very, very bad day. And just to prove it out and to show you what's actually happening, I have even more detail. So this is fun. I love talking about this because it's good for people to understand how load looks on our system and how load probably looks in your home. People are very predictable, okay? In the middle of the night, nobody's using power. It's very little consumption here, okay? Then people wake up and there's usually a little bit. You know, you got your coffee going, you got your lights on, you're getting in the shower, that kind of thing. Then you go away for the day. You're out for the day. Maybe you come home at lunch, maybe you don't, but then you have the dinner time peak. And this is really what we have to build our system to, right? This demand right up here. It doesn't matter if the rest of the day we didn't use anything. Right up here is where we have to build our system to. And this peak is unfortunately right where people are charging their vehicles. That's what I would do. Come home from work, plug in my vehicle, and go about my day, which is unfortunately when I'm normally peaking my electric load. So what do we do about this? What can we do? Well, you have to come up with something that's called demand-side management. You need to have a relationship with your customer. Everyone needs to know what's going on, and I probably need to incentivize you to do this. But if I can convince you, if I can pay you a small incentive to charge your vehicle up overnight, you'll still be charged up in the morning, no problem. But instead of putting that load right where we cannot have it, instead it comes in the middle of the evening, right? So here it is. It starts at 11 p.m. and you're done charging by 5. You're still fully charged, no impact to your day-to-day behavior, but you saved our electric system quite a bit of grief, especially that distribution transformer, that poor guy's cooking out there. So this is what we're going for, right? These are the systems that some utilities have rolled out. These are the systems that we're going to be working on. Now, keep in mind, a lot of these systems are a lot easier to roll out with advanced meters. Data is important, and I'll touch on that in a bit, but this kind of work is very important to do, and we need the technology to do it, okay? So that's the first step. Let's get rid of that red peak. Now it's gone, okay? Good. You've moved your load into the middle of the night. Demand-side management successful. We've saved our system peak, but we can do even better. Now, this is where the next step is. This is where it becomes a distributed energy resource, not just a demand-side management tool. What if you came home, same thing, plug your vehicle in, go about your dinner. Not only does it not charge, doesn't charge there, but instead, now it's actually charging back. Now you're actually using the battery capacity in your vehicle to put energy back on the grid or into your home, okay? So now we've taken a situation where I'm paying you a little bit to charge up in the middle of the night, and I'll pay you a little bit to actually use your battery to power your home at dinner time. right? And this looks great, right? Let's say you come home and you're at 65% battery, because people don't consume their whole battery every time they leave. They think they do, they don't, unless you're on a big road trip. You come home at 65%, you discharge your battery back to your home or back to the grid, takes you down to about 50%, 45%, and then you charge up overnight, and you're still back up to 100% by the time you left. So now I, as a utility, have paid you a little bit of money, may have paid for your whole charge, and I've saved a lot of grief on our neighborhoods. Because even if your peak only cuts here, and I still have to build your peak to here, well, guess what? Your neighbor didn't participate in this program. Shame on them. Shame on them. So I need you to provide power to the system. So I actually need it on the system level, okay? And that's when it becomes a distributed energy resource. Okay, so what is another example of distributed energy resources? Now you know what you're doing. You're going to go buy an electric vehicle. You're going to come participate in this program, and you're going to power my grid for me. It's awesome. Well, that's not the only thing we can do. Of course, we know of solar. We know of wind. We know of battery storage, the vehicle to grid I just explained. I'm going to focus on solar and battery storage because I think they work really well together, okay? Battery storage is interesting because people think it saves a lot of money. It does, but it doesn't save on consumption. If I charge up a battery overnight and then I discharge it the following day at that peak time, it's done a good job of reducing my peak, right? I had peak capacity overnight. And we know that from looking at this. And it reduces my peak during the day, just like this. That's fantastic. But I've actually still used the same amount of energy to power that battery. I've just shifted when it's all happening, okay? And that's why it's a good tool, but they all have their pluses and minuses. Batteries don't save on your usage or your consumption. They save on your peak. Solar is quite a bit different. It actually saves on your usage. It's generating. It's putting kilowatt hours into your home onto the system. The challenge with solar, oh, yellow, not great. I apologize. But you know what? I'll explain it. You can see it. Solar generates when it's sunny. I know, revolutionary. I just dropped a bombshell on you. But solar generates when it's sunny. That's unfortunately not when our peak is, right? So here we go. We have this challenge where solar is putting energy on the grid, not when we need it, but when it's sunny. That's the same as wind. Wind puts energy on the grid when it is windy, not necessarily at that exact moment that we need it. So what do? You pair it with battery storage or other distributed energy storage, okay? So what happens is your solar charges up your battery during the day, and then your battery discharges during the peak. And that way you're able to pair these distributed energy resources together to be super effective in managing your system, okay? Distributed energy resources are a volume game. It's not like I put up one solar and one battery and I'm done, game over. No, far from that. Distributed energy resources are distributed. We want customers to be participating in this. We want neighboring municipalities to be participating in this. We want everyone, commercial businesses, us as the city, we want everyone to participate in this, and you integrate all of these resources together. That's how you're going to effectively mitigate a lot of the investment that's needed to build our electric system up in the future. So, as I said before, the history of power has been unidirectional. Generate, transmit, distribute, consume. Now we need to get into a new era where instead everyone is generating, everyone is storing, everyone is using consumption. It's all over the place. Yes, it takes a lot as a utility to integrate all of this stuff together, but if we can accomplish that, we can save a lot of money on our capital investment. We don't have to build bigger poles and wires, and we can save a lot of money on our upstream bill. And if you don't know, FortisBC bills us, that's about 85% of the total cost of us operating our utility. It is by far and away the majority of the cost. We run pretty lean outside of the power that we buy from Fortis. If we can start collecting our own resources and storing energy to use it at opportune times, we can keep that Fortis bill low, which then we can pass on to you as keeping our rates lower. Okay, a little bit of battery here. So as I said, this is just an example of how you can actually pair those two systems together. Again, I'm looking at it from a grid level, but you can absolutely do this from a home level, right? Here's an example where someone's put a Tesla Powerwall, and I did take this from their PDF, and they paired it with solar. So their solar is charging up while they're not there, right? Now, we have a program at the City of Penticton where you can sell us your solar energy back to us, and we'll buy it from you one-to-one. We pay you the same rate as you pay us for a kilowatt hour. We are essentially your battery. This is a fantastic program. I view it as more of an incentive, because honestly, we have to do something with that power on the other side of the meter. So at some point, the rate will change, and you won't get as much back as you buy from us. But for now, we're equivalent to a battery. In the future, when that rate changes, this project becomes much more appetizing, because what it means is that you can charge a home battery up in the middle of the day when you're not home. You're not consuming any energy. You're at work, you're out at the library, you're watching my presentation. Well, your solar's at home cooking along, charging this battery, and then when you go home to cook dinner, that's when your battery's discharging into your house. So this works on a small scale, this works on a large scale, and that's why we need everyone to participate. Okay, so what does the future look like? Well, as I said, we need information. I'm not sure if you know, but I barely know what I consume at home. I don't know what is my biggest demand. I'm thinking about it, I just moved. It's probably some of my appliances, maybe my dryer. I don't know that. I would love to know that. You need detailed metering information to understand that. Advanced meters will give you 15-minute interval data. You will understand how much power you're using in 15-minute intervals. Right now, when we collect data from a meter, you get one read. How much power did you use in an entire month? Period. That's it. You don't know when it was, you don't know what it was, you don't know how it was. All you know is how much you used one time per month. So we need more information. You need more information as a customer if you're interested. I need more information on my city. I need to understand which areas are going to overload first, and the best way to do that is to know granular level every single home. And I know there's some big brother creepiness here with this. Don't worry, everything is privatized. If you do not want to participate in any of these programs, you are not required to. That information that we have is anonymized, and anything that we're doing is for the purpose of building out the system, not looking at you as an individual. Okay, the next is the bidirectional relationship. As I said, I've sold you power for a long time. It's time for you to start selling me power. It can be solar, it can be your battery in your vehicle, it could be a battery mounted in your garage, but it's time for a bidirectional relationship where I'm working with you and we're together solving this energy problem. Incentives. I gotta pay you to do it. I gotta pay you to do it. I'm not expecting you to do it for free. I'm not expecting you to feel energized after this presentation to go home and start giving me power for free. I gotta pay you to do it. I know that. We're coming up with incentives. And lastly, we wanna fully utilize our assets. Right now, you may have capacity at your home for an EV charger. And if your electrician comes in and takes a look, they have to use code rules to tell you, yeah, looks like you might, or in my case, up in my home, I'll use my old home in West Kelowna as an example. I had a 100 amp panel, okay? By the math, according to Canadian Electrical Code, I had to get a service upgrade to put an EV charger in my home, or a heat pump, anything like that, okay? That service upgrade, by the time I pay an electrician to replace my panel, I pay my utility, I pay all my fees, probably about 5,000 bucks. It's no small fee, and that can differ, so don't take my word on it, that can differ. Now, if I had my smart meter data available to me, what I could do is I could prove that over the last 12 months, I actually didn't consume enough to justify a service upgrade. I only need a 40 amp charger that fits perfectly fine on my existing panel. And that's what this data, that's what this information can provide to us. This is a Canadian Electrical Code rule that you're allowed to utilize if you're a FortisBC or BC Hydro customer, because they have this level of granular data. We don't. So when you see these projects come forward, these are the reasons. It's beneficial to you, it's beneficial to me, it's the way of the future, and that's why we're trying to move towards this. We want to fully utilize every transformer, every electrical panel in your home, everything we have in the ground. If we're going to make it through this electrical transition, we need to fully utilize it, okay? And lastly, I just want to mention this. The DSM and the distributed energy resources, they're great tools, and I genuinely believe that we will implement them and they will save us a lot of money on investing in our system. But as I pointed out with all the electrification coming, there's no amount of DSM or distributed energy or battery storage that's going to fully negate the need to invest in our system, okay? We are going to have to build bigger poles and bigger wire at some point. Now, we can kick that out, and if we do a good job of kicking that out, it can be very cost-effective and very efficient. But that's why we need all of these tools together, and don't think just because we put enough batteries out there that we don't have to ever upgrade our system. We're going to need every tool in our belt to get through this. Okay, closing remarks. Reduce. I cannot get through this presentation without pointing out the fact that we can just use less. That is totally available to us. It's free. It is an unheard of concept. Can we just use less power? Can we do less? It's not very aligned with society today, but it's something that we should really try and consider and talk about. Can we walk instead of taking a car? Can we go outside instead of watching TV? These are things that could, at a large scale, have an impact on how we operate our system. And next, as I pointed out, we will need to do capital upgrades. And lastly, please, 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 when I start coming out with these pilots, participate in them. Join me. Let's see what we can do together. It'll be some fun. There'll be some bumps and bruises, but I promise you'll be incentivized to do it, and it'll be a learning process that'll benefit everyone. Okay, is there questions? Go ahead. Oh, how much time do I have? Okay, great question. Okay, so Yes, okay, yes. So a lot of condo buildings around, multi-unit residential buildings, we'll call them MURBs around Penticton. How do we transition these that have multiple units, have a single transformer that feeds the entire building? How do we get there with those buildings? It's complex, it's challenging, it's technical. But luckily, we know what we're doing, okay? So the Strata Act was recently updated to include a new resolution, Bill 22, that says you have to get an electrical planning report, an EPR, okay? An EPR will tell you exactly your question. It takes an analysis of your electrical system, and then it'll say, if you wanted to add a heat pump, if you wanted to add EV charging, if you wanted service upgrades, this is what it would look like, this is the upgrade path, this is the costs expected, these are the utility costs, all in a nice summarized report. That report is actually required to be included if I were to buy a condo in a strata, that is actually required to be included. Now this is a new change, it's brand new, and you have until 2028 to do this, to take advantage of this. And for an EV Ready plan, there's a separate program, okay? So this is the Clean BC Go Electric Rebate Program. You can go through this rebate program that will do a very similar analysis of your electrical system, tell you how much capacity you have for EV charging, and then it's the first step of a bankrolled situation that'll take you all the way through to execution of the installation of the chargers, okay? Now, as I said, you kind of need an electrical consultant or a contractor to do this. It's quite a bit of work, and there can be quite a bit of costs. And I'm so glad you asked that, because we as the city have recognized this, and we're trying to step in and help these stratas out. Okay, we have programs that will pay for your EV Ready plan. And as a result of the changes and the complexity of this, we're just going to increase the program to also pay for your EPR, your electrical planning report. One-stop shop. So in the next week, it's actually, what is today? Oh, you get advance notice. On Thursday the 8th, there will be a news release going out that the city is going to open up this program for applicants. And if you want to participate, if you want your strata to have an EV Ready plan and electrical planning report paid for by the city, we will help you out with that. We're not going to pay for your whole infrastructure. We're not going to put EV chargers in, and I won't buy you an EV unless you ask really nicely. But we will help you with these first steps to get through this complex technical requirement that's going to answer your question, because it's individual to every single building. Go ahead. Great question. Offset some of that electric load. So the question, again, for the camera, was just, the Housing Task Force here in Penticton predicted that 78,000 people will actually be the population soon. We're about 37 right now, I think, about 37,000. Right now, I think. Yeah, or right now? A lot of growth, either way. There's a lot of growth coming, and that growth needs to be offset by something. So yes, we do already have building policy in place that your building has to be solar ready, which means that the roof is being constructed with the structural requirements to put solar panels on top, and there's been a conduit laid for you to put electrical wiring through should you want to put solar on your system. And further to that, I'll actually add one more, another program for stratas. At the end of the week, we're going to be announcing that we actually have an energy audit program, because there's lots of energy audit programs for residential buildings. There's not nearly as many for MURBs. And so at the end of this week, we'll be announcing a program that will do a MURB energy audit, give you opportunities to look at, can we install solar as part of that program? So look for that at the end of the week. Great question, great question. We are doing a better job of our webpage being updated, so we're putting all of these programs out there so people can see what's available today. But it is nice to think of a one-stop shop. Who can you ask? What can you go to? We will be trying to set that up. Right now, we have a general electric utility email inbox. I'm happy to field questions directly myself, actually. I think I don't have my contact up here, but I will provide it if anyone wants it as an email out to this group. And feel free to email me, but for a faster response, just go to the general electric utility inbox. We also have the climate action inbox as well. And both of our teams, now that we're one department, are going to be looking at that together. So we'll be making sure that we're ready with all of these new programs coming out for some of those questions. So go to the website first off, and if there's any more questions on that website, will be the electric utility email, or you can email me directly. Go ahead. FortisBC Hydro. So Site C is a great example of this, right? Site C is a dam that's being built in northern BC right now. Now, it's a hydroelectric generating station. That's great. That's clean, renewable energy, and we need it, as we just pointed out. That is predicted to only really kick the can down the road to early 2030s. So the solution is not Site C. We will need more. And that's a question that I don't think we have a really solid answer for. What we know today is that we need to start utilizing tools like this to help mitigate that need out as far as possible. And when that need comes, well, then we need to be prepared for it. There's new technologies being developed. What we don't want to do is buy coal power from Alberta or something like that, right? That's a huge step backwards. We're not saving anything in terms of environmental impact. So it's a great question. I wish I had a better answer for you. Site C will kick the can down the road a little bit with clean, renewable hydroelectric generating, but I don't think we'll build another hydroelectric generating station. This is personal opinion. This is not, I don't think we'll build another one, honestly, in BC. I think it's not, it is clean, renewable energy, but it's not zero impact to the environment when you create a dam and when you flood a valley, right? There is damage to that area, and there is First Nations who are responsible for those areas in the Site C's case. So we need to be aware of that. We need to be considering all of that when we move forward, but we do need energy, and that's going to be a complex solution that we'll need in the future. But hey, we got another few years for it at least. Go ahead. Moderate, I'll say. It's you definitely, if you're looking for a payback, it's way better now than it used to be because the cost of panels has been driven down with the rapid adoption of this technology. But in terms of how much you're generating in the winter, it's not going to be nearly as much as you're generating in the summer, obviously, and we're not going to have as effective generation from solar as a place like Phoenix, Arizona, or California, right? There you can barely drive around without seeing a solar panel on the roof because they're basically able to power their own homes for the duration of the year. So in the winter, you should definitely still be prepared to be a consumer of power from the city. And in the summer, you may generate more than you use. And that's depending on, again, cloud cover and everything that goes along with it. There is really good solar studies, and some of them are even free tools you can look up online where it'll zoom in on your, Google has this, it'll zoom in on your roof, and it'll show you where panels would be best situated and how much you could approximately generate. And of course, I think that pushes through to a sales option and somebody's trying to sell you solar, but it's a cool tool. And if you can find something like that online, you can get a better idea of your specific situation. But it's a good question. Winter, be prepared to be a consumer. Summer, be prepared to be a generator. Go ahead. Absolutely, absolutely. And that's, sorry, the question here again is, I want to be able to generate in the summer and consume in the winter from my own solar panels. So how much do I need to do that? And is there ability to do that within the city? The answer is today, yes. With the rates that we offer you, we charge you the same kilowatt hour that you charge us to buy that energy. You are essentially using us as battery storage. So if you have a really good summer of generation, you keep that in a bank, and then that bank is consumed over the course of the winter. Now, we do have a buyout option that if you take it at the end of the year and you go, ooh, I generated more than I consumed, then I want to buy it out, we'll just give you a check with it. But if you wanted to just keep it rolling in a bank furthermore, you're absolutely able to do that. But again, that will, once the rates change, that won't be as equal in terms of battery. Go ahead. Yes, great questions. I'll address them one at a time. So the first question is, solar isn't, it's a statement and a question, solar really isn't that efficient. It's not really going to be a long-term solution for us in BC in meeting our energy needs. I don't fully disagree with that, actually. I think it's a part of the pool of resources, right? Everything, as I said, it's a volume game. We need every ounce we can get. Solar is not as efficient in BC as it is in those southern states. That's absolutely true. And if we were required to run 100% off solar, your bill would be very expensive. I'll say that. There's a reason why, public-run and private-run utilities, Fortis and BC Hydro, they haven't put massive solar banks across BC because the cost of doing that, the cost they'd have to sell you power would be so much greater than what we get of our hydroelectric generators that it wouldn't make sense. It doesn't make sense from a business investment. It doesn't make sense to you as ratepayers to be subjected to that increase just because they wanted to put up solar because they thought it was an interesting technology, right? Solar panel costs will need to come down so drastically to meet the level of costs that we supply from hydroelectric generation that it may never happen. Now, that being said, what do we do if we run out of hydroelectric generation? Then we really need anything, because then cost is out the window. Solar can still add energy onto the grid. It should be considered as a technology that can be used, but I would agree with you that we can't look at it as the saving grace. It's the same as wind. Wind only generates when it blows, and it's not very windy in Penticton very often. Wind might not make sense here. Micro hydro. Can we put a hydroelectric generating facility on the dam, right on the channel? Or what about our dams up in Ellis Creek that provide us water? All of these things we've thought of and said, oh, this is it. This is great. It's not that great in terms of cost. We need these costs to make sense because ultimately, as fun as all of this is, you have to pay for it. I have to pay for it out of my pocket, not as a professional, but as a resident here. So, these things are important to us, and there'll be resources in the pool, but they may not be the single entity that solves everything. Okay, and the second question is about EVs. How do we get DC energy in a battery back onto the grid, which operates in AC? Great question. So if you look at what Ford is offering right now, Ford F-150 Lightning, they say, power your home, power your home. What they don't tell you is about this $5,000-ish of equipment that you have to install as a rectifier to take DC energy and put it back to AC. Now, some cars have the ability to do this. If you take a look at the Hyundai Kia platform, okay, they can back charge. So anytime you take AC power from the grid and you're putting it into your battery in your car, there's an onboard circuit called a rectifier that is taking AC energy and it's converting it to DC. Now the ones in some models of car, and I'm sure there's going to be more in the future, have the ability to operate backwards as well. Not at the same level, right? So the Ioniq, the Hyundai Ioniq and the Kia EV6, they can take energy up to about 20 kilowatts at level 2, all the way up to the max. But they can only put energy back out at about 3 kilowatts because that's their reverse rectifiers, or that's the converters that are rated for that. So it's a great question. It is something that needs to evolve with technology. Right now, Ford seems to have the best platform, but they require you to have an external converter to take it from DC to AC, which is not cheap. Correct. So his comment was just that at some point previously, there was a council discussion about using solar to store energy, essentially using the grid as a battery and then buying it back at the same rate. And then you could generate in the summer and consume in the winter and basically be net zero over the course of an entire year. That actually is in place right now. That's what I'm talking about with the rates. And what you're talking about is accurate. So let's take it from this perspective, okay? So right now, you buy solar from me I buy solar from you and you buy power from me. Same rate, 1-to-1. Well, if I'm buying solar from you at 12 cents per kilowatt hour, but I'm buying power from Fortis at 6 cents per kilowatt hour, that 12 cents that I paid you in solar that's going on the grid, well, that's being subsidized by everyone else who's paying me. Because if you don't have solar, wouldn't you want your supplier to be buying energy at 6 cents per kilowatt hour instead of 12 cents per kilowatt hour? So it is a bit of it, and that's why I call it an incentive rate right now. And that it's 1-to-1, and that seems fair to a lot of people, but in actuality, if you're not selling me energy at the cost that I can buy it from someone else readily available, then I'm incentivizing you and you're being subsidized by the other ratepayers, right? So that's an important comment. It's important understanding. That's why I assume council decision rates will change in the future. A valid concern. Climate change is happening. We're starting to see rivers dry up, or at least less water. Freshet is what it means when all the snowpack melts off, comes down the riverways. It's not as strong as it used to be. It is a valid concern. As of right now, especially with Site C, hydroelectric is still going to provide us what we need, but it means that we do need to be looking at alternate solutions. That's why it contributes to my thought that perhaps we will not build another hydroelectric generated large scale in BC. We need to look at other solutions. Okay, go ahead. Oh, it's a great question. Again, here. So the question again, sorry, I forgot to read that last one. This one is, has City Council considered creating time of use rates? So a bit of an explanation first. Time of use rates. Power is cheaper from 9 p.m. to 10 a.m., and it's more expensive from 10 a.m. to 2 p.m., and it's very expensive from 2 p.m. to 9 p.m. And what this is, it's essentially trying to manage our demand on the grid, right? So what we're trying to accomplish is don't use your power in between 2 p.m. and 9 p.m. if you can help it, right? There's some things that you won't. You're not going to cook dinner at 9 p.m. because of power. You're just going to do it at the time. But if you can, could you put on a load of laundry later? Could you run the dishwasher later? There's some things that you have within your control. Time of use rates are a way of supporting that transition, okay? Council does not have the ability to consider it at this point because our metering technology does not support it. Right now, we don't have an advanced metering platform that we're moving to. We're going to undertake an investigation this year to understand the costs of what that would look like, and ideally probably start rolling it out in a small pilot, perhaps new builds, perhaps a subset of customers that want to participate in some of these programs. They'll get these advanced meters first, and we'll roll out from there. But the municipalities who own their own utilities are the last ones to go, right? Fortis and BC Hydro already have this technology. New Westminster is the other municipality that runs their own electric utility. They're now started that off, and we're going to be trying to work with Penticton, the Nelson, and the Grand Forks in our area here to try and get some cost efficiencies large scale. Perhaps, again, this is all very preliminary, and look into creating that program so that council can make that decision in the future. Yes, ideally we'll be coming up with technology solutions that won't require a meter upgrade to do some of this. Now, of course, it'll be installing some extra hardware in your home or something like that. So it's not for everyone, I would say, but for advanced users who are very interested, I want to know what I'm using. I want to prove to my wife that I don't have to wear a sweater tonight. Whatever you want to do with it, yeah. Get on this pilot program that we may be coming out with in the near future. It will require some other additional things beyond meters, but it's coming for sure. Go ahead. Yes, so sorry, I keep forgetting to answer questions to the. So what he's asked here is there used to be a study that covered micro hydro generation on the channel. Okay, so this is building out the dam of Okanagan Lake and putting in essentially a turbine to generate power off of that channel sluiceway. So yes, it was considered. It was part of a generation study that we've completed, and we've actually moved beyond that and continue to look at all of our distributed energy resources and generation sources. The problem with that project is that, again, the cost of power to sell to you as just a result of that, factoring in the capital cost of installing this equipment and then the overhead of maintaining it long term, it would be 2-3 times the cost of power that you pay today, because we pay 6 cents per kilowatt hour to Fortis. If we can't beat that 6 cents per kilowatt hour, it's not a project that we want to consider. We would consider it if the province gets really scrambled and says, hey, we need all energy sources, we'll pay for them outright, those kinds of things. We're upstream supply constraint, we're panicking, and they offer up the money, then we'll do it. Of course, there's a ton of options for distributed energy resources, but while you pay the bill, we need to make sure that it's as low as possible. As much power as we can buy from other suppliers, we are. So the way that the power market works, again, the question was, can we look at expanding Grand Coulee Dam? Is there more generation capacity there? What options do we have to meet the needs of our society as we grow into this? And the answer is, we're doing everything we possibly can as long as it's cost effective. And as soon as we're out of generation sources that are cost effective, we'll look at ones that aren't cost effective, because then they become cost effective. Now, what that means, though, is that you have to buy power from the market, okay? So we buy power from Fortis. We don't play in the market unless you want to be our market, then we'll start to participate with you. But FortisBC, BC Hydro, they play in the bigger power market. They're buying and selling power all the time. They have their own generation sources in Frechette. They may have a surplus of power that's then shipped out to Alberta, down into America, anywhere else. And in cold winter months where we have a lot of demand and not a lot of water flow, we're buying power, we're bringing it back in. It's a bit of a dirty little secret, but people don't know this. In BC, we actually do buy coal-fired generation power. We have to at certain times of the year, otherwise we're not being heated. So, as we grow, this is going to become more of a concern. That market is going to be really important, because any source that we can get that's zero emissions will be even more important into the future there. But yeah, every project's being looked at. We'll buy from the market. Lots of systems are interconnected to do this exact goal. Okay, we're just running out of time. I'll do one more. Great question. So I'll speak back to my Fortis days, right? This is when I was working in the transmission group and looking at load forecasting, large-scale load forecasting, right? Entire system load forecasting. Luckily, they forecast every day with a million different scenarios. And if you look at any of what's called the LTERP, that's FortisBC's long-term electric resource plan, they have to submit this, I think it's every year, but really it might be every 2 years, to the BC Utilities Commission, addressing that exact question. Scenario A, EV adoption happens immediately. Scenario C, EV adoption doesn't happen. And they forecast all of this out, and they talk about what they'll need for transmission lines, where they're going to get their sources, and what they're going to need for substation transformers, because those projects take quite a bit of time too. It's not just the transmission line that reaches your city, but once it's there, it actually has to connect to a big transformer that may not have the area that's required. So FortisBC is looking at building substations in, where was it, Fruitvale? I know they were looking at one recently. I don't know how that shook out, but substations, transmission lines, these are part of the bigger picture. They forecast very well. As much as this electrification comes quickly, as I've kind of alluded to, there is actually time at that level to forecast out that long. And yes, they're looking at it every single day with multiple scenarios and trying to figure out when they need to make that investment. Okay. Thank you.